Hello, Algebra 1 CP students. Hopefully you're having a good day so far. Today, before we get started with graphing linear functions in standard form, I would very much like to review our slope-intercept form, especially since it's on video. And just the way the schedule worked out, we didn't happen to have any video lessons on graphing good old y equals mx plus b. So if you could, I'd recommend pausing the video, probably take about maybe 5 to 7 minutes, see if you can tackle these four graphs on your own. We'll go over them when you're done. So again, pause the video, come back to it, and we'll go over these four problems. All right, by now I assume that you have paused the video, you've tried these on your own. We're going to go through them now together, and then we'll learn how to graph linear functions in standard form. Okay, so starting with this first problem here, first one, again, all of these are written in our slope-intercept form. Our slope-intercept form is y equals mx plus b, in which m represents your slope, or your rise over run, change in y over change in x, and b represents your y-intercept. Okay? So if I'm going to graph things like this, I would first want to identify that information. I'd want to say, well, what actually is the slope and what is the y-intercept? Sorry, I'm like looking around for a ruler right now. I knew I had one nearby, so I can draw some nice straight lines. So in this first function, I would say, well, this 1/2 occupies the position of m. So I would say, well, that right there, it must be my slope. And again, that's rise over run, so that would be a rise of 1, or vertical change of 1, over a horizontal change, a run of 2. And this would be my y-intercept of -3. So I would go ahead and start at my y-intercept of -3 on the y-axis. Keep in mind that this is the x-axis, this is the y-axis, right? And a common student mistake is to start at -3 on the x-axis. Please don't do that. We start at -3 on the y-axis. And then I'm going to graph this by following the slope of going up 1 over 2. So take a look. From here, I'm going to go up 1 over 2, follow my rise over run. Rise of 1, run of 2, same deal, up 1 over 2. We're getting right to the edge here. If I want to keep going, up 1 and over 2. And if I wanted to extend it in the other direction, I could just follow the pattern in reverse, preserving that constant slope by going down 1 over 2. And I would join all those points together to make a nice, neat line. Try to do the best I can here. That wasn't bad. There we go. From that picture, we could then identify some pieces of information. The slope is given to us, notice, at the very start, but we can see that reflected in the graph that I drew as well. You should be able to see that on the graph. We could, where's my colored pen here? We could see from any one of these points to any one of these other points that we drew in, we would have a rise of 1 and a run of 2. That constant slope shows up throughout the graph. Additionally, we'd be able to see our y-intercept of -3. So our slope would be 1/2. Our y-intercept right here is at 0, -3. And our x-intercept is the only one that we have to really hunt for, and it's this right here, the point at which we cross the x-axis, and I would say it's at 6, 0. Okay, so there's my slope, my y-intercept, my x-intercept. All right. Again, slope and y-intercept are given to us right out of the gate. It's really only the x-intercept that we have to hunt for. Okay. Same deal over here. When I see this negative sign in front of the x, it's not just a floating negative by itself. It doesn't mean that there's no slope. It means that our slope is -1. Or if you prefer, you could write it as -1 over 1 to get it in that rise over run format. Okay. You don't have to rewrite it like that, but if you feel comfortable doing so, then by all means. This +4 is your y-intercept. So I'm going to do exactly that. I'm going to start at 4 on the y-axis, right here. And I'm going to follow my slope of moving down 1, rise of -1, and over 1 to the right. Remember, the -1 means we're going down to the right. Down 1, right 1, down 1, right 1. And we're just going to keep doing that until we have enough points that we can go ahead and sketch a nice pretty picture. Again, if you wanted to extend it in the other direction, you could move up 1 and left 1 to do exactly that. And then I would connect each of these things together and form that nice linear function. So I'm going to do exactly that right now. Connect those points just like that. Bam. Linear function. Okay. Once again, we can identify from that the slope from any one of these points to another one of these points. We see the rise over run, -1 over 1. We should also be able to notice the y-intercept of 4 show up on our graph right here, 0, 4. And we also see the x-intercept of 4, 0. Again, the only one that we're not given right out of the gate, but it's still just a matter of seeing it by looking at the graph and identifying it. Hopefully those went okay. The last two are just a good example, a nice reminder of vertical lines and horizontal lines, respectively. So y equals -2. Remember, when you have y equals a constant, that's going to be a horizontal line with 0 slope. It's almost like if you had y equals 0x minus 2. And you could say, well, that's going to be a horizontal line that goes through the y-axis at -2, right here. Horizontal line, like that. Here's your y equals -2. The y-intercept would be, in fact, right here, of course, 0, -2. There would be no x-intercept, and your slope would be 0 in this case, because a slope of 0 means you have exactly that flat horizontal line. Okay. Conversely, when you have x equals just a constant, x equals a constant is a vertical line. And the vertical line would occur at x equals 3 and just extend vertically from there, because all of these points are those that are 3 units away from that y-axis. Okay? Your x-intercept in this case would be 3, 0. There would be no y-intercept because it would never hit the y-axis, and your slope is undefined of this particular graph. Okay? Cool. So hopefully that was a nice review of y equals mx plus b. Let's see how we can now graph linear functions in standard form. Ready for it? Let's do it. Okay. Suppose we had this example of a standard form graph. Where'd my examples go? This example that I had prepared, it's right here. Okay. Of a good standard form graph. Suppose I had 2x, oh sorry, 2x minus 5y is equal to 10. Okay? 2x minus 5y is equal to 10. Unlike y equals, clearly this is not y equals mx plus b, not like we've seen before. Unlike our slope-intercept form, standard form of a linear function is written as ax plus by is equal to c, where a, b, and c are just constants. Okay, so it's ax plus by is equal to c. Unfortunately, it doesn't really give us much information right off the bat. It's not like slope-intercept form that gives us the slope and the y-intercept like right out of the gate. So you might be like, why even bother with standard form? Well, you're going to see a little bit later that a lot of word problems translate very directly to standard form versus slope-intercept form. So this is a little bit more useful when we're actually dealing with applications. Okay? Now, how do we sketch the graph of that? Do we just give up and like cry and walk away? No, we could still approach this, even though it's not quite as simple. We could still approach that in a reasonable way and try to sketch a graph of that particular function. All right, how do we do that? I'm so glad you asked. First things I would do here is there's really two good approaches to take for a standard form graph. What you could do first is you could find the x and y intercepts. That's a good strategy number one. Okay. Remember, we talked about how to find the x and y intercepts algebraically. There is a video on that as well. You could go back and rewatch if you need to refresh yourself on how to find the x and y intercepts algebraically. But all you need to do to find the x-intercept, you plug in 0 for y. To find the y-intercept, you plug in 0 for x. and you just use those and find your X and Y intercepts. Once you find your X and Y intercepts collectively, you can go ahead and just draw a line that connects them together, because all you need to sketch a line is just 2 points, right? Once you have 2 points, you can just connect them together, and that's how you end up with a line. All right? I'm really struggling to find my examples that I prepared for this video. I had them all written down nice and neat, and now I don't know where they went. I found my first example. I don't know where this is. I found them. They were at the bottom of the pile, of course. Okay? In any case, let's go ahead and do it. We can find our X and Y intercepts by first plugging in 0 for X. So I can find my X-intercept by plugging in 0 for Y, right? So I would say that my X-intercept is 2 times X minus 5 times 0 is equal to 10. If you recall, that's because any point on the X-axis rather would have Y coordinate of 0. So that means that 2x is equal to 10, and therefore x is equal to 5, meaning that my X-intercept is at the point 5, 0. Okay? To find your Y-intercept, you can plug in 0 for x, because conversely, any point on the Y-intercept would have an x coordinate equal to 0. I would say 2 times 0 minus 5y is equal to 10. So that means negative 5y is equal to 10. We would divide both sides by negative 5 to undo that multiplication and end up with y equals negative 2, meaning that our Y-intercept would be 0, negative 2. So now that I have my X-intercept and my Y-intercept, I can just go ahead and sketch a graph. I'll do exactly that right now. Okay. Oh, I drew my thing too far over. That's all right. Let's draw a nice new graph down here. I could go ahead and sketch a graph and just say, I need to draw it on this side. I tried to account for the fact that it's shifted over like an X-intercept of 5, and I drew my line on the wrong side. I could say, well, here's my Y-intercept at 0, negative 2. Here's my X-intercept at 1, 2, 3, 4, 5, 0. And I can now just connect these two lines together, and lo and behold, we have a graph of a linear function. Bam. That would be my graph. Okay? From that graph, you could then extract the slope and the X-intercept and the Y-intercept. This time, X and Y-intercepts would be given to you, and you would find the slope by saying, well, what did I do to get from this point to this point? I went up 2, and I went over 1, 2, 3, 4, 5. So your slope would be 2/5, 2 over 5. Okay? That's strategy number 1. You could find your X and Y intercepts, plug in 0 for Y, plug in 0 for X. You can go ahead and plot your X and Y intercepts on the graph and sketch it. Strategy number 1. Strategy number 2 is, instead of finding your X and Y intercepts, what you could do if you feel comfortable is you can convert to y equals mx plus b. You could take what you have and convert it to your slope-intercept form, right? If I have 2x minus 5y equals 10, and I want it to look like y equals mx plus b, that means I want y alone on the left side, and I want everything else to move over to the right side. So in order to accomplish that, we can subtract 2x from both sides. That would give us negative 5y is equal to negative 2x plus 10. Notice I wrote the negative 2x first, because in our y equals mx plus b, we would want that to come first. I can then divide both sides by negative 5 to get y alone. And that will give me y equals negative 2 divided by negative 5 is positive 2/5 x. 10 divided by negative 5 minus 2. And notice that's exactly the graph that we see here. We have our y-intercept of negative 2. My slope is up 2 over 5. And then you could go ahead and sketch exactly the same graph that we just did. All right? It's pretty much, in my experience, been a 50-50 split on which students prefer which method. Some students like, because it's already laid out in an easy to solve form, some students like to just plug in 0 for y and just solve that, plug in 0 for x, solve that, we get our 2 points, sketch a line. Some students like to say, well, I already know how to graph y equals mx plus b. That's my comfort zone. So if we can turn it into y equals mx plus b, then I can just do what I already know. All right, whichever strategy works for you, I'm totally fine with you doing the problems that way. But just, you do have to master one of them. So whatever strategy works for you, you could go back and forth if you really want to, but, you know, pick whatever works for you and roll with it. Okay, let's do a couple more examples of how that's done. Maybe, actually, you know what? Let's do one more example, but done in the 2 different ways. I think that would be the way to go about this. Let's do the one more example, but done in 2 different ways. Here we go. Ready? Let's do 4x plus 3y is equal to 6. Okay, great example right there, standard form graph. Again, for strategy number 1, we recognize that this is in standard form because it's ax plus by equals c. Strategy number 1 is we can find our x and y intercepts. Okay? To find your x-intercept, you would plug in 0 for y. So you would say that 4x plus 3 times 0 is equal to 6. That would give us 4x is equal to 6. And if we divide both sides by 4, we're going to get that x is equal to 6 over 4, which is a fraction that reduces down to, let's see, divide both by 2, 3 over 2, or 1.5. Okay? So I would say that my x-intercept is at 3/2, or 1.5 if you prefer, comma 0. Your y-intercept, in order to do that, plug in 0 for x, I would say is 4 times 0 plus 3y is equal to 6. 4 times 0 is just 0, so we get 3y is equal to 6. And therefore, dividing both sides by 3, I would get y is equal to 2. Which means that our y-intercept is at the point 0, 2. So now that we know the location of our x-intercept and the location of our y-intercept, we can go ahead and sketch a nice graph. And I can say, well, our x-intercept is at 3/2, or 1.5, 0. Just because it's a decimal doesn't mean we can't do it. It's right there. Our y-intercept is 0, 2, right there. And now that we have those 2 points, we can just connect them together to form the graph of our linear function, like that. Okay? Hopefully that makes sense. Here's our x-axis, here's our y-axis. If you don't like finding the x and y intercepts algebraically, I tried to do it earlier so that you kind of are getting comfortable with that. But if you don't like that for whatever reason, you could, of course, convert to y equals mx plus b instead. Right? So let's start with our 4x plus 3y is equal to 6. If I want 4x plus 3y equals 6 to look like y equals mx plus b, that means I want y alone on the left-hand side of the equation. In order to accomplish that, I would subtract 4x to move that 4x over here. That would give us that 3y is equal to negative 4x plus 6. Again, I elect to write the negative 4x first because I know that I want my function to look like y equals mx plus b. And lastly, in order to undo that multiplication of 3 times y, I'll divide both sides here by 3. And it gives me y equals negative 4 over 3. I'll just leave. I can't reduce that fraction. Negative 4/3 x plus 6 divided by 3, 2. If you notice, that's the same exact function that we end up with here. My y-intercept is positive 2. My slope is very interesting. It's down 4 over 3. Notice that is reflected here. 2, 3, 4 over 1, 2, 3. Lands right back on that line. Yes? And our x-intercept is right here, which we'd be able to find. Okay? So regardless if you graph this way, finding your x and y intercepts, or converting to y equals mx plus b, whatever works for you to graph something in standard form. All right. Hopefully that was helpful. Hopefully that made sense. Again, on any sort of assessment, you'll be able to choose which of those methods you want to do. You'll still have to know how to do them. Like, there may be a problem asking you to find the X and Y intercepts of something. So it's still something you should be aware of how to do. But if there's just a question that says, and there will be, graph something in standard form, whichever of these methods you want to do in order to accomplish that is completely fine. Okay? Thank you for your attention and focus today. I hope you have a great rest of your day. It's a rainy Monday, so hopefully the weather clears up and we can continue some great algebra going forward. All right? Thank you, everyone, and have a great day.